Okay, we are back. And this time we're working with parallel and perpendicular lines, more specifically the slope. So we want to determine if lines are parallel or if lines are perpendicular by using their slope. There's only a few scenarios that can happen. So let's talk about it. First, let's recall a few things about slope. And we've been reviewing this for a while. Slope is rise over run. We have a formula, y2 minus y1 over x2 minus x1. And positive slope means it's an uphill, negative slope downhill. A horizontal line has a slope of 0. We should never say no slope. There is slope. The value is 0. In a vertical line, slope is undefined. So horizontal means that there is no rise. 0 is in the numerator. So this is 0 over some number, which equals 0. There's a value. The value is 0. For undefined, the rise is, there's no run. The denominator is 0. So this is some number over 0, which is undefined. If you try to divide by 0 in a calculator, you're going to get an error. It's undefined. It doesn't make sense. That's not a hill, that's a cliff. However you want to think about it, the vertical line has slope that is undefined. 0 is in the denominator. So we have to be able to simplify some fractions correctly. 0 in the numerator, 0, 0 in the denominator, undefined. The other thing we want to recall from algebra is slope-intercept form of a line. Y equals mx plus b. M represents the slope, and b represents the y-intercept, or where the line crosses the y-axis. Now, we spent time at the beginning of geometry course reviewing this, coming from algebra, and it's things that we're expected to know. So first, let's find slope. Now again, slope is y2 minus y1 over x2 minus x1, rise over run. So when in doubt, label your points. x1, y1, x2, y2. Then you can plug it in and work it out. So I'm just going to bring the work over here. y2 minus y1 is 4 minus 8. x2 minus x1 is negative 4 minus 6. So we have a negative 4 over negative 10. Well, the negative over negative cancels out. And then we reduce to 2/5. So m equals 2/5. That's telling us that if we plotted those points on a number line, we would get an uphill line. Now, a slope of 1 is a 45. Rise 1, run 1. Rise 1, run 1. That would be a 45-degree angle. If it's less than 1, it's lower than a 45-degree angle. More than 1, higher than a 45-degree angle. Let's look at another, number 2. Again, we can label things x1, y1, x2, y2, and simply plug it in. So I'm going to bring it over here. y2 minus y1, negative 6 minus 6. For the x's, x2 minus x1. Substitute carefully. We get negative 12 over positive 6 for negative 2. So m slope is negative 2. That's downhill because it's negative. And it's more than 45 degrees, so it's pretty steep, but going downhill. And again, you can graph these on the coordinate plane. For number 3, it looks like we have 5 minus negative 7 4 minus 4, that's 12 over 0. This is undefined. It's a vertical line. And if you graph it, you will see that. The x value for both points is 4. Number 4 is in slope-intercept form. Y equals mx plus b. So m is whatever's in front of x. Slope is -3. And the last question here, well, we can plug in numbers and test it. We can graph it and figure it out. Or we can rewrite it in slope-intercept form, which is what I would suggest. Rewrite in slope-intercept form, which means get y by itself. So let's add 4x to both sides. -2y equals 4x plus 8. And then we'll divide by -2. Divide everything by -2. We get y equals -2x minus 4. And now that it's in slope-intercept form, we can see the slope, m equals -2. Okay, so we can find the slope of a bunch of different lines. We're going to use slope. Remember, we started off saying we're going to use slope to determine if lines are parallel, perpendicular, or just plain old intersecting lines. Like, those are the only choices. Either lines are parallel or they intersect. Now, sometimes they intersect in a special way, perpendicular. So let's look at that. Well, parallel lines are going in the same direction. So parallel lines have equal slopes. Parallel equals slope. Perpendicular lines their slopes multiply to a -1. So you can see in the example, 1/3 times -3 is -1. Another way to say it is that perpendicular lines have opposite reciprocal slopes. Opposite means change the sign. Reciprocal means flip the fraction. So if I want to test whether lines are parallel, I can get their slopes right here and say, okay, is one the opposite reciprocal of the other? Yes. Or I can multiply them to see if it multiplies to a -1. Let's do it. So this is what it looks like. We did this before. Slope of AB is 2 over 5. Any line that has a slope of 2 over 5 will be parallel. So think about that. If AB has a slope of 2/5, then any line parallel to it will also have a slope of 2/5. But any line perpendicular will have a slope of -5 over 2. Flip the fraction, change the sign. Same thing in number 2. The slope of the given line is -3. So any line parallel will also have a -3 slope. But any line perpendicular will have a slope of +1/3. If one is going downhill, the other one has to be going uphill to be perpendicular. So let's see. We're asked to find the slope of a line that's parallel to the given line and perpendicular to the given line. So let's take a look at number 1. First, let's find the slope of CD. Well, that's y2 minus y1. Negative 6 minus 6. X2 minus x1. Negative 12 over 6, or negative 2. Now, we did that before. Slope of any line parallel is also negative 2, because parallel lines have the same slope. Slope of any line perpendicular, flip the fraction. This is negative 2 over 1. So we're going to flip the fraction and turn it positive. It was a negative number, now it's a positive number. It was 2 over 1, now it's 1 over 2. Slope of EF. Well, you can work it out, but we did this one a few minutes ago. It's undefined. We got 12 over 0. It's a vertical line. It's like the y-axis. Well, again, and slope of any line parallel will also be undefined. Slope of any line perpendicular, flip the fraction, so 0 is on top now. So it's 0. We would change the sign, but there's no such thing as negative 0 for us, so it's just 0. So think about that. Vertical is the y-axis, horizontal is the x-axis, and they're definitely perpendicular. And number 3. And again, we did this question 2 minutes ago. We rewrote it in slope-intercept form, and we found out that the slope was, whoops, these screens are not meant for lefties. We found out that the slope of this line was negative 2. So any line parallel will also have a slope of negative 2, and any line perpendicular will be a positive 1/2. Very much like our first example. We want to determine if the lines LM and HG are parallel, perpendicular, or just plain old intersecting. So on the plane, there's only 2 things that can happen. They're either they don't touch or they do touch. So parallel or intersecting. Sometimes when they touch or when they intersect, they're perpendicular. So again, same slope, parallel, opposite reciprocal is perpendicular. Anything else is just plain old intersecting. So what do we have to do? We have to find the slope of LM. So how are we going to find the slope of LM? 1 minus 5, 3 minus negative 2. That's negative 4 over 5. The other segment is HG. So we're going to find the slope of HG. 2 minus 7 over 0 minus 4. That's negative 5 over negative 4, which is really just 5 over 4. Now observe, they're not the same, so they're not parallel. These are definitely intersecting lines. Now the question is, are they perpendicular? Well, is one slope the opposite reciprocal of the other? So take one, flip it, and change the sign. Do you get the other? Or multiply them together, and do we have a product of -1? The answer here is yes. These are perpendicular. So again, if I take -4/5, flip it, and then make it positive, I get the other one. So yeah, they're perpendicular. The other way is multiply them. -4/5 times 5/4, and we get -1. So again, yes, they are perpendicular. We're just going to do the same thing over. We need the slope of LM. Slope of LM, 1 minus -3. 2 minus -4. That's 4/6, which is 2/3. Always reduce your fractions. If you don't reduce your fractions, you might not see that things are equal. So for HG, work out your slope. 5 minus 7, -2 minus 1. That's -2 over -3, which is 2/3. If you didn't reduce 4/6, you wouldn't know that they're the same. Well, these have the same slope. These lines are parallel. In number 3, we need to find the slopes. Rewrite them in slope-intercept form, just the way we practiced before. (5x minus 2y equals 6). Subtract 5x. Divide by -2. Y equals 5/2 x minus 3. The slope is 5/2. Rewrite HG. In this case, all you have to do is divide by 2. And you will find the slope is -5/2. Well, they're not the same. One's positive, one's negative. They're not opposite reciprocals. These are plain old intersecting lines. Nothing special about them. And finally, we might be asked to write the equation of the line. So we can write an equation that's parallel or perpendicular, but we might be asked to write the equation of the line. And we did this at the beginning. Let's do one of these. First thing we're going to do is find the slope. So I'm working on number 1, slope of LG, -8 minus 6, 2 minus -2, -14/4, -7/2. Step 2, we're going to plug in x and y to find b. So we're using our model equation of slope-intercept. We're going to use one of those points. It does not matter which one. It makes absolutely no difference. pick one of them, and we're going to say y equals mx plus b. So y is -8. Slope is -7/2. X is 2 plus b. That's -8 equals -7 plus b. So b equals -1. And then step 3, we're going to rewrite the equation filling in m and b. So we're going to take our m, and we're going to take our b, and we're going to plug it in. Y equals -7/2 x minus 1. We're taking our m, and we're taking our b, and we're just plugging them in. That is the equation of the line. If we wanted parallel, we would use the same slope and a different point. If we wanted perpendicular, we would get the opposite reciprocal slope and whatever point. But we need to be able to write the equation of a line. Okay. All right, so we're going to call it there. Using slope to determine if lines are parallel, perpendicular, or just intersecting, and using any slope and a point to write the equation of a line.